Right, today's topic is on trigonometry. So let's do a recap on how we can find trigonometrical ratios of the three trigo functions. Right, so what does Tuakaso means? The letter T represent the trigo function's tangent. So for short form, we use TAN. So it's TAN of an angle. So it's TAN theta, TAN 30 degrees, TAN 45 degrees, so on and so forth. The letter C represent the first letter of the trigo function cosine. So short form is cos, so it could be cos 45 degrees, cos 30 degrees, so on and so forth. And the letter S is the first letter of the trigo function sine. The short form is SIN. Alright, so we start off with using a right angle triangle. And let's identify the angle that we're interested in. Let's call this angle theta. Right. So there are three sides to the triangle. There are three sides. So the side that is opposite the angle theta, we're going to label it as opposite. And then the side that it's adjacent to the angle theta, oh sorry, so the opposite, the first letter is the letter O, right? And then the sides that's adjacent to the angle theta, we call it adjacent. And then the first letter we identify using letter A. And of course the third side, which is the longer side, that is the side that's opposite the 90 degrees, and that's, we call it the hypotenuse. Alright, so what does TOA means? It means, TOA means the tangent of an angle. So let's say, for example, this angle that we're interested in is theta. So tangent theta, it's equals to, is a ratio. It's by taking the length of the opposite sides over the length of the adjacent side. And the value you get, it's equals to tangent theta. Right, so TOA, so that forms the letter TOA. Okay, so it's actually a ratio, right? A ratio where you take the length of the opposite over the length of the adjacent, and the value you get is equals to tangent theta. So theta can be any angles that is more than 0, less than 90. It's in the cube angle. So how about car? So cosine theta, it's the ratio where we take the length of the adjacent divided by the length of your hypo. Right, so if you take the first letters of all the cosine, adjacent, hypo, it forms CAH. And finally for sine, yes, so for sine, it's the ratio of taking the length of the opposite sides divided by the length of the hypo. And if you take the first letter of each word, it forms SOH. Okay, so this is Tuakaso. Right. To begin off, let's learn about some special angles. So what are the special angles? They are namely 30 degrees, 45 degrees, and 60 degrees. So there are many angles out there, and why are these three angles so special? Because the trigonometrical ratios of these angles can be expressed as exact form. All right, what does it mean? So let's look at the next slide. All right, again, let's start off with a right angle triangle, because the trigonometrical ratio can only be applied on a right angle triangle. So let's say we're interested in this angle 30 degrees. and we want to find the ratio for sine 30. Right, so you can use the calculator to evaluate sine 30, and you will get half. Right, so remember earlier on we say that sine of any angle is actually a ratio where we take the length of the opposite divided by the length of the hypo. So in this case here, the opposite is actually equals to 1 unit. The hypotenuse is equals to 2 units. All right, so we need to find the length of the adjacent side. And because this is the right angle triangle, we can use Pythagoras theorem to find the length of adjacent side using a squared plus b squared equals to c squared. So a squared will be c squared minus b squared. So a will be square root of c squared minus b squared. So which is equals to square root of 2 squared minus 1 squared, that gives you square root 3. So the adjacent side has square root 3 units. So from this diagram, we can go on to find the ratio for cosine 30. So to find cosine, it's taking the length of the adjacent over the length of the hypo, so which is square root 3 over 2. Likewise for tangent, opposite over adjacent, you can get 1 over square root 3. And if you were to recall that we can actually rationalize 1 over square root 3 by multiplying with the square root 3 over square root 3. So that ends up getting square root 3 over 3. 1 over square root 3, if it times square root 3 over square root 3, you'll get square root 3 over 3. Because square root 3 times square root 3 gives you 3. Alright, so in summary, this is what we have. We have sine 30, we have cosine 30 degrees, which is square root 3 over 2. We have sine 30, that is 1 over 2, which is half. We have tangent 30, that is 1 over square root 3 or square root 3 over 3. Alright, so this is some things that we need to recall early on in the chapter on angle properties. You should have learned that cosine theta is equals to sine of 90 minus theta. So if let's say your theta is 30 degrees, so your cosine 30 is equals to sine bracket 90 minus 30. 90 minus 30 is 60. So cosine 30 is equals to sine 60. Right. So in other words, cosine 30 is square root 3 over 2. Sine 60 is also square root 3 over 2. Okay, and then for sine theta, you can find it by taking cosine of 90 minus theta. So if your theta is 30 degrees, sine 30 is actually cosine 60. So these two angles are called complementary angles. So tangent theta is 1 over tangent bracket 90 minus theta. So if your theta is 30 degrees, so tangent 30 is 1 over tangent 60. Right. So 1 over tangent 60 is equals to tangent 30, which is 1 over square root 3. Right, so tangent 60 will be just square root 3. Right, so we have managed to find the trigo ratio of 30 degrees and 60 degrees. Right, sine 30 is equals to cosine 60. Right, and then tangent 30 degrees is equals to 1 over tangent 60 degrees. So we're going to continue to find the trigo ratio of 45 degrees. Trigo ratio of tangent 45, sine 45, and cosine 45. So likewise, we start off with a right angle triangle, and we're interested in 45 degrees. Right, so tangent 45, you can easily use the calculator to evaluate, and you'll get 1. And you can actually write 1 as 1 over 1 because 1 divided by 1 gives you 1. Why do you want to do that? Because we want to express it as a ratio. To find tangent, we take the length of the opposite side divided by the length of the adjacent side. So in this case here, we let the opposite side to have 1 unit, adjacent side also 1 unit. And then we're going to use Pythagoras theorem to find the longest side, which is the hypo. And that will be square root of 1 squared plus 1 squared gives you square root 2. Alright, so from here, we can easily find the trigo ratio of cosine 45 and sine 45. So cosine 45 is adjacent over hypo, so 1 over square root 2. If you rationalize it, you should get square root 2 over 2. And likewise for sine 45 is also 1 over square root 2. Right, it makes sense because sine 45 is actually equals to cosine bracket 90 minus 45. And 90 minus 45 is 45. So hence sine 45 is equals to cosine 45. Right, so in summary, right, this is what we have learned. So this table will not be given to you in the exam. Right, it will not be given to you in the exam. So the best way is to find a way to memorize it, memorize all the values for all these trigo ratios of the special angles. Right, so it helps to remember that, let's say sine 30 is half, and then you can actually draw the right angle triangle and then form all the three sides, and you use like what you have done in the earlier slides, and then from there you can actually find cosine 60. Otherwise, you just have to memorize it. Right, so what are some possible questions involving special angles? For example, you are asked to find the exact value of all the questions that has been stated there, and it says without the use of a calculator. So what does it mean by saying without the use of a calculator? It means to say that you can't use a calculator to punch in 2 and then cosine squared 45 degrees plus sine squared 60. All right, you can't use a calculator to work this out, because if you use a calculator to work this out, the answer you get may not be exact. There will be a lot of decimal places, right? And this is not what they are interested in. They are interested in getting exact value. So what are exact value? Exact values are what we have seen earlier on, like values like square root 2 when there's no a lot of decimal places, right? Like square root 3, right? So not exact values of things like 1.24685 so on and so forth, where you can there's no end to it, a lot of decimal places behind, and those are not exact. But you can actually condense all this number into like square root 3, okay? That is called exact, right? Okay, so let's look at part 1. Right, so before we look at part 1, let's recall what we have learned earlier. So what we have learned earlier, special angle, right? So we know that sine 30 is equals to cosine 60, 60 equals to half. And then we learn that cosine 30 is equals to sine 60 equals to square root 3 over 2. Tangent 45 degrees is equals to 1. Right, we also learned that tangent 30, it's 1 over square root 3. And tangent 60, tangent 30 is 1 over square root 3. So tangent 60 will be square root 3. So these are what we've learned so far. Right, so we need to make use of this information. So let's look at part 1. So 2 cosine 45 degrees plus sine squared 60. Alright, so cosine squared 45 means, what does cosine squared 45 means? It means cosine 45 multiplied with another cosine 45. Then sine squared 60 means sine 60 multiplied with another sine 60. This is what it means. So cosine 45, oh, all right, we forgot to write down the value for cosine 45. Cosine 45 we learned earlier on is 1 over square root 2. Sine 45 is also 1 over square root 2. Right, so sine 45 is equals to cosine 45 equals to 1 over square root 2. So that plug in values. This is 1 over square root 2, 1 over square root 2. Sine 60 is what we have here. Sine 60 square root 3 over 2 multiply with another square root 3 over 2. Okay, so this is what we have. Let's write 2 as 2 over 1 fraction. Multiply numerator. 1 times 1 is 1. Multiply denominator. Square root 2 times square root 2 is 2. Multiply numerator, multiply denominator. So you have 2 times half gives you 1. 1 plus 3/4, so 1 and 3/4. Alright, so this is how you can solve questions involving special angles. Alright, let's continue to solve the remaining questions. Okay, let's recall all the trigonometric ratios of all the special angles that we have learned earlier. Right, let's look at part 2. So we have tangent 60 degrees plus cosine 60. Right, so tangent 60 is equals to square root 3, and then cosine 60 is equals to half. So the answer is just half plus square root 3. Right, so if you use a calculator to evaluate, you're going to get a lot of decimal places. Right, and that is not exact. All right, that's not exact. Right, let's go on to the last questions, that is part 3. Okay, there's something here that I need you to recall, and that it's 180 degrees, right, is equals to pi radian. Okay, pi radian is equals to 180 degrees. Right, so sine pi over 3 cosine pi over 6 minus tangent 45 degrees. If you were to convert that, you will get sine 180 divided by 3, that will give you 60. So we are basically finding sine 60 and cosine 30. Okay, then minus tangent 45 degrees. Right, so sine 60 from the table here is square root 3 over 2. Not the table, sorry, on the record that what we have written or what we have learned earlier on the right hand side. All right, sine 60 is square root 3 over 2. Cosine 30, cosine 30 is also sine 60, which is square root 3 over 2. And then tangent 45 is 1. Tangent 45 is 1, yeah. Right, so you multiply numerator, that gives you 3. Multiply denominator, that gives you 4. So 3/4 minus 1, that gives you negative 1/4. All right, let's see. Time for you to put what you have learned into practice. All right, so if we do it correctly, you should get the answer for part I to be 1/4. Then for part 2, let me give you a hint. You can write 75, express 75 as two special angle. Of course, you can write it as 20 plus 55. Right, but we're not going to use that because 20 and 55, they're not special angle. You can write it as 10 plus 65. Again, you can do that, but it doesn't help because 10 and 65 are not special angle, right? So what are the special angle? Will be 30 and 45. All right, so you can write 75 as 30 plus 45, and then you can use the to expand it, you can use your addition formula, which we revise later on, but I think I can just give you the formula and then you can try to do it. Alright, it's not difficult. So you can let angle 30 degrees be A, then 45 degrees let it be angle B. And I think the answer you should get would be, square root 6 minus square root 2 over 4. Okay, try it.